Hello everyone, welcome back to Advent of Code 2024. We're going to do day 14. Although I realize I haven't really looked at this at all yet. What is this? Like, it looks like this is like the number 10 or something? Maybe? A 1 and a 0? And then it's got decorations. Oh, is this Advent of Code's 10th anniversary? It is. Right? Because, well, 10th anniversary is a weird way of putting it. It's the 10th time, it's the 10th year, right? Because 2015 was the first one. So, yeah, after this, they'll have done 2015 to 2024, which will have been one every year for 10 years. I see. Okay. And you know what? I bet it's got decorations from all the previous 9 years. This Christmas tree is the first year. I don't remember that much of what any of the others were. I think, was it last year that there was the island where you were like following star, or it was like a series of floating islands, you're following stars to the top and then back down to the bottom? One of them was a city. That was like year 2 or 3, I think. I don't know. Anyway, I'm finally thinking, hey, what is this? And it's a 10 for the 10th anniversary. Of course, not like the most subtle thing in the world, but I just hadn't thought of it before. Day 14, restroom. So here's an interesting Redoubt. It's Redoubt, isn't it? What syllable do you put the accent on? Let's look that up. It should be Redoubt, right? Yes, that is what the dictionary says, Redoubt. Day 14, restroom Redoubt. Restroom Redoubt. One of the historians needs to use the bathroom. Oh, and there are historians. So we're talking about the past this year, right? Okay. Fortunately, you know there's a bathroom near an unvisited location on their list, and so you're all quickly teleported directly to the lobby of the Easter Bunny headquarters. Unfortunately, EBHQ seems to have improved bathroom security again after your last visit. The area outside the bathroom is swarming with robots. To get the historian safely to the bathroom, you'll need a way to predict where the robots will be in the future. Fortunately, they all seem to be moving on the tile floor in predictable straight lines. You make a list, that's your input, of all the robots' current positions and velocities, one per line. So P is XY, and V is X and Y, okay. Now, technically, we don't actually care which is called X and Y. We can relabel these if we want, unless something later in the problem statement is going to tell us about it. Okay, actually, we do care because the bathroom is not square. 100 tiles wide and 103 tall. Suspiciously prime sounding. Okay. So the robots outside the actual bathroom are in and look at that. The robots in this example is 11 by 7, 2 small primes. Okay. The robots are good at navigating over under each other. I see. So that's why it's important that the boundary is primed. They're going to bounce off the walls, and it's useful for the dimensions to be co-prime. They can share the same tile and don't interact with each other. Yeah, so that's cool. These robots have a unique feature for maximizing bathroom security. They can teleport. Oh, it's a torus. They don't bounce off walls. Okay. So this is going to be like a modular arithmetic thing, right? Here's what robot, okay, blah, blah, blah. Yeah, so, wait, what is its velocity? 2 to the right and 3 down. Sorry, what? I see that it's gone 2 to the right, but it looks like it's gone down by 4. 1, 2, 3, 4? Okay. And here, it again, no, hang on. 1, 2, 3, 4. So there's something I'm not understanding about how it wraps around the edge. Where will the robots be after 100 seconds, rather? Yeah. Count the number of robots in each quadrant after 100 seconds. Yeah. Robots exactly in the middle, horizontally or vertically, don't count. Huh. Yeah, I don't understand. Its position is 2. Okay, what? Okay, it must be... Oh, have I been reading this backwards? Because I was thinking, okay, they're using a different coordinate system. This is 0, 0, not this. Probably. Well, no. What? How is this 2, 4? Okay, let's... I mean, it should say here, x and y given in tiles per second. X is the number of tiles from the left wall. And y, number of tiles from the top wall. So, are they saying that this, like, cell doesn't, this doesn't exist? But there are 7 rows. Okay, let's see. So yeah, -2 is going up. Oh, so it was the coordinate system I thought at the beginning. Yeah. Positive x to the right, positive y down. So position 2, 4 should be... I guess this is 0. Yeah, if this is 0, 0, then we're 1, 2, 1, 2, 3, 4. So that makes sense. I understand the position of this robot. If its velocity is 2 minus 3, it should be going 1, 2, 1, 2, 3. Ah, that's where it is. Okay. I guess I somehow convinced myself, despite thinking I was doing the opposite thing, I just did the same thing. So it's going up because y is negative. Then it goes 2 over and 1, 2, 3 up. Okay. And it makes sense kind of that I thought it was off by 1 because if I was treating -3 as if it were +3, I mean, mod 7 -3 is actually 4. So I was off by exactly 1, and that's why I was confused every time. Okay. So you can even consider the x and y coordinates separately. They're basically asking you, take the robot's position. No. Take the robot's velocity, multiply each of its components by 100, add its initial position, and then reduce mod the dimension, right? And that'll tell you their final position. Now, I imagine part 2 will just make the numbers bigger, perhaps, probably, in fact, even so big that you can't do the multiplication and stay within a reasonable integer size. But, like, I mean, how big could it be? If you use arbitrary size integers, like, you know, give it 100 digits or something, no problem. I can multiply 100 digits by 5 or whatever, and then reduce mod some other number, and it won't take very long. There are tricks to do this more efficiently than just multiplying. I can't think what they're called, but where you do successive squares to find out the powers of 2 that make up the component of the number you want to multiply by, and anyway, it minimizes repeated work. But it doesn't seem like we should have to do that here, because they can't really give me a number big enough that arbitrary integers won't cut it. So maybe part 2 will be something else? If they're asking me to have the robots actually collide with each other, I mean, you almost have to fall back to simulation because that's so chaotic. Also, why are the robots labeled 1 and 2? Number of robots. I see. Okay, well, I guess the conclusion is I can't predict what part 2 will be, and so I'll just do the obvious solution to part 1. Well, perhaps you might find doing the simulation more obvious, in which case this is the second most obvious, but easiest. So, what's my input look like? This, of course. So we need we need a parser. I don't think we really need anything else. Right, we don't need to import any other libraries. Import text regex applicative. We need match string. Yeah, I guess. Want many, I assume. And decimal parse the ints. Data robot type coord. I'm going to actually use coordinate as a parameterized type today. I guess I could use v2s, but well, actually, no, I don't need v2. It's fine. I'm parameterizing this so that I can in just one place change to integer if I end up needing to. So robot of A is a robot of 2 coord A's, right? Yeah. They have a position and a velocity, which are both coord of A. Our input is a list of robot of int. So here is where I'll actually choose a concrete type. Well, actually, yeah. Well, the thing is, kind of funny. Part 1 and part 2, Their output type... Oh, their output is always an int, yes. So if I change the input to be integer, the output of part 1 and part 2 should still be int. I was thinking it would be kind of nice for part 1 and part 2 to be polymorphic. But they are. All I have to do is change input, and they'll be fine. They won't break because their input and output types suddenly don't match. Okay. So this is the one place where I'll fix the integer type that we're using. So let's write a little parser here. Maybe identity error no parse match input, where input is many robot followed by a new line. A robot is robot mapped over yeah, I mean, I guess coord labeled P, but then also ignore a space, and then a coord labeled V. And we could, I suppose, put the new line here, but I've already handled it up here, so I don't know. I mean, that seems fine, I guess. And coord of label is a tuple of the results of parsing. Well, I don't know. String, no. Yes, string of label equals, but ignore that and then parse I don't know, let's put this here. Ignore that and then parse a decimal. And then ignore that and or ignore a comma after it. String comma. That makes sense, right? Yeah, I'm already skipping the space here. Yeah, this looks good. Is this? Oh, maybe the arguments to maybe are in the wrong order, of course. Okay. No parse, I hate you. Okay, what do I have wrong? Well, I guess the first thing we can do is make these all top-level functions so I can actually test them. Match coord of 5, 10. No, coord, right, coord P of P equals 5, 10. All right, yep, didn't parenthesize that. So that parses. Is that what my input actually looks like? Yeah. So, oh, I didn't handle negative numbers. That's fine. Okay, there is a function in TextRegX applicative common to do that. What is it called? It might be signed, I'm not sure. It is, yeah, signed. So signed is a function that, well, here, that takes as input a parser and produces as input another parser. So you can take a parser for numbers, for positive numbers only, and enrich it to handle negative numbers. So I need that. Out of curiosity, it actually does handle plus. So it handles both plus and minus, and also there being no sign listed, which is fine. Okay, so we could just say sign decimal in both places. I guess I will. We could also extract out like signed decimal as a thing called int and then just use int. But all right, I won't. Okay, so now it parses just fine. Okay, so let's move these back. To being internal functions, so that it's excusable to not give them a type signature. Okay. And I think what we want is like a function. What are the constraints? I think I need like integer and rational. No, not integer. That's crazy. How do you? I guess I need integral, right? To do modular arithmetic on it. So it's eventual something. Final position takes an integral a, well, requiring the day's integral, it takes a start and a step, a mod, and a step count. So it takes 4 ints? Yuck. I kind of don't want to just pass 4 ints because it's so error prone. I want to define a data type that has these as arguments, just so I can give names to them. So, I mean, let's do that. Data, what do we call it? Mod problem of A is a mod problem containing start, pause, velocity, room size, num steps, all of which num ticks, all of which are of type A. Shouldn't even need to derive show because I'll never print one of these, but so I think integral's all I need. I mean, what is the type of mod? Yeah, that's pretty much all I need. So final position of mod problem of P, V, S, and N. Here, I can afford to give them cryptic short names. I mean, I can afford to do whatever I want, right? I'm writing this program. I'm God, but I think it's not excuse me, been a lot clearing my throat a lot today. I don't think it's a crime against readability to do it here, because the client to final position, can refer to the definition of mod problem to see, hey, what do all these ints mean? What order should I put them in? And it's quite nice for them to be short names here, because it's just easier to read mathematical expressions when the numbers are when the variables have short names. That's why, algebra classes use X and Y instead of, sometimes just you don't know what the variable is and you call it X. It's abstract enough. But sometimes you say, oh, here's, how many hours it takes to do a thing, and they still call it X. They don't call it the number of hours to do a thing. Anyway, it's just more readable if expressions are shorter. So I think it's just P plus, I don't need the parentheses here, V times S mod, no, not S, N mod S. I think that's it, right? Oh, I wonder, couldn't I... So what you could do, I'm going to write a function in a minute that takes a robot of A, provided A is integral, and produces a position, its final position, a pair, right? And what you could do is you could break apart the robot into two things, two coordinates, pattern match it, right? And call final position twice, and then extract the result of each and put them back into a robot, or into a coordinate. But is there something funny you can do with functors and maybe applicative or something here? Like, what if robot derived functor? Would that help? No. Because position and velocity, I don't want to do something to both the position and velocity. I want to do something to the left half of position and velocity, and something to the right half of position and velocity. So, I don't know. Maybe this is not the ideal way to represent. This is a good way. This is what we want to parse. Maybe we could massage it into some, two different equations, one in X and one in Y, and then map over the result, once in the Y dimension and once in the X dimension. But I don't know. I'm not going to do that. So I think then, this is like one-dimensional. Let's say 1D here. And then final position 2D. Takes two A's, which could be a coord of A, like indicating the width and the height, but I don't like representing that as a coordinate. It's an ordered pair, but it's not a coordinate. I don't know. So I could take a pair of A's, but at that point, why not just take two separate A's? takes a robot of A and produces a coord of A, I think. No, I need also a step size. Yeah, this is kind of annoying. I need another A. So it seems like width, height, and step and n are kind of their own object that deserves to be bundled up. I don't know. Maybe I'll just get away with using 3 of them here, and we'll see how it looks. Width, height, n, robot. Just pattern match the robot, actually. Robot. Ugh. Yeah. X, Y, and dx, dy is final position 1D of mod problem of start pos is x, velocity is dx, room size is width, and numtix is n. Mod problem y dy height n. You know, I think it does make sense to have width height be a size, actually. So let's say type size of A is, I'll call it room size of A is AA. Oh, annoying that room size here is just a single number. It's not a problem. There's no name conflict or anything, but it's awkward for room size in one condition to mean. Well, I'll leave it as is, I guess. So really here we should take a room size of A because, remind me why I thought I would want this? Right, because I'm going to need to pass the room size object to the function that determines the quadrant. Oh, also, negative numbers, huh? I think actually mod does the reasonable, the thing you expect with negative numbers, which is a refreshing surprise compared to other languages where the percent operator is actually like the remainder operator and behaves weird with negative numbers. I think it actually works the way you want. So like, what is -2 mod 5? We'd like it to be 3, right? And it is 3. Okay, great. Thanks. So I don't have to worry about negative numbers. It all just falls out magically. Maybe now would be a time to test final position 2D before I do anything else. Multiple declarations of velocity? Oh no. Yeah, that's true. There. So let's grab an input from the examples. So the only example they give us that has an answer is this. And they don't even tell us the answer. We have to look at it after 5 seconds. And see that it's at 1, 3. So let's let... What functions do I actually have to call here? I want to call final position 2D, right? Yeah. So let R equal prepare of this in final position 2D, which takes the room size first, right? Width, height. So in the example problems, the width is, just reading the, okay, width 11, height 7. And the number of steps we're taking is 5. Yes, I'm aware it's a partial pattern match. And the result we get is 1, 3, which is what I wanted, right? 1, 3 is here. Perfect. Okay. Cool. So that seems to work. So what we need then is a function that tells us what quadrant a robot is in, I think. It's kind of annoying because, like, we want a maybe. We could, okay, so, like, we could label, how does the problem statement discuss this? Each quadrant, yeah. So they don't actually... they don't label them at all. So we could just arbitrarily say, oh, this is quadrant 0, quadrant 1, quadrant 2, quadrant 3. And we could write a function that produces maybe a quadrant. And if it's in here, it produces nothing. If it's one of these, it produces just a number. I think that's kind of... I don't know. Maybe it's fine. We could also, like, call the middle one of, like, the 5th quadrant and just have robots report which of the 4 or this they're in. But it's kind of nice to have the middle part be distinguished because then you can use the magic of map maybe to just drop things out, I think. I suppose you don't really need quadrants, do you? You need halves. You can say, which half of the room are you in horizontally? Which half of the room are you in vertically? Each of those returns a maybe bool. Like, yeah, oh, I like that. What if we had a function that took a width and an x and produced maybe bool? Like, the function could be named, are you in the left half? And a robot in the left half will say just true. A robot in the right half will say just false. And a robot in the middle will say nothing, I'm not in either half. And then you can tuple up the results of calling that twice. Yeah, that's cool. And then we'll have a, a pair of bool bool. And we can use that as the key in a map and group all of the robots by, not even group, we don't even need it to be a map. It can be, well, yeah, because we want the value to be an int, basically. We want to do a frequency count of that bool result, dropping out all the nothings. Yeah, okay, that seems very cool. Let's do it that way. In left half, it takes a integral a and an a and an a and returns maybe a bool. In left, well, let's say first half, so it's not quite so dimensionally suggestive. Or lower half or something. Lower, yeah, I don't know. Lower half of size and pause. I think what we want to do is case compare pause with. So what would the middle of a size be? If we had like 3, for example, were the width, 0, 1, and 2 would be the spots. So I think we want to div the dimension by 2. Size div 2 of, if it's equal, it's exactly in the middle, we return nothing. If the position is less, we return true, and if it's greater, we say false. So we can test that real quick. Map in first half of 7 over the integers 0 to 6. And we should get 3 just trues, a nothing, and then 3 just falses, right? Perfect. Okay. And then we can say quadrant takes a room size of a and a, called it coord a, and returns maybe two bools. Quadrant of width height x, y is tuple up the results of in first half w and x with in first half of h and y. That makes sense, I think. So I think we're finally ready to write part 1. Well, I guess we need data map, don't we? To get frequency counts. In principle, like you can do frequency counts using lists with like sort and group, but it just makes more sense to do maps. import qualified data map as m. Part 1. Can I write this as compositions of some functions? I think so. Oh, we're also going to need, as I said, data maybe, map maybe. Let's see. We're going to, we have a list of robots. That's our input, right? Well, robot of int as it happens, but we're going to want to call final position 2D on each of them. So let's say product. Really? Takes a list of A? No, it doesn't. It's a lie. Okay. My Emacs support is so out of date that it's telling me it wants a list. Fine. Yeah, so product will work on a map by... So a map is foldable, producing all of its values. So if you call product on a map, you get the product of its keys, which is what I want. Product of freaks, which we'll have to define again. I've done that many times. Map may be quadrant. Yeah, that makes sense. Before that, how do we get the robots? Okay, we need to say, I call it final position 2D? Yeah. 2D of 101, 103? Is that how? Yeah, it's 101 wide. 103 tall. And the number of steps is 100, right? Actually, we can do it like that. Is this type check, you think? No, because I haven't written freaks yet. Where freaks is m from list with plus map 1. So we take a value, we make it the key, and we use 1 as the value. That seems right. Quadrant. That's true. I have to say, okay, hang on. So size is this. Any better now? Yes. It's a number. I'll try it. That's the right answer. Great. So, let's review. Anything I'd like to change about this? No, I'm pretty happy with it, I think. I'm glad I finally found a pretty way to categorize robots by quadrant that, like, doesn't involve having to enumerate 4 possibilities, basically, and do a bunch of math. I just have 1 division and 1 pattern match, and then, like, a map. Well, it's not exactly a map, I guess. It's this. I mean, yeah. And the nothings just kind of fall out magically through map maybe. I don't have to pick them apart myself. Anyway, I like it. Git add p. Yeah, well, I like all of this. No need to split. Git commit day 14 part 1. All right, let's see what's going on in part 2. Oh, wait, what? During the bathroom break, someone noticed the robots seem awfully similar to ones built and used at the North Pole. What? What does this even mean? Am I supposed to look at the... What? What do you mean, into a picture of a Christmas tree? You're not going to tell me what that means? You're going to make me simulate this and display pictures and look at them and tell you which one is an Easter egg? That can't be right. What is this bullshit? I know Advent of Code, at least once a year, does some image-related thing. Where, like, it gives you a grid and you're supposed to print the grid and look at it and be like, is, you know... Usually it's like, oh, the... You know, here's a way to produce, you know, a grid that's 7 tiles tall and 35 tiles wide, and if you look at it with your eyes, it obviously is a sequence of 6 letters or something. But what is this? A picture of a Christmas tree. I guess most of the robots. What does this even mean? So a few of them will be... This is horrible. I hate this. Because, like, what if the number of seconds is 1,000? I don't want to spend 1,000, like, I don't want to hit space 1,000 times while I look through all my, or enter or something, 1,000 times while I look through a bunch of pictures. It would be nice to have some, like, understanding of what makes something a Christmas tree. Like... I imagine. I don't know. Also, it's 100 by 100. So even rendering the image in a you're gonna have to have a big terminal. I can't make my terminal 100 tall. Are you insane? I can make it 100 wide. What? I'm a little bit tempted to skip part 2 here, which I'm not very happy about, because part 1 was, I don't know, I mean, it was a very simple problem, but it did let me discover a couple interesting things, right? But this idea of, in first half, and, you know, well, I guess I was right earlier when I was reading the problem and I said I could not predict what part 2 would be. I could never have predicted this. Nobody could predict this. What is a property of a Christmas tree image that we could exploit here? I assume the... How many robots are there? 500. So To make a plausible looking image on a canvas of dimensions 101 by 103. That's 10,000, a bit more than 10,000, right? Cells. We only have 500 pixels to draw with, at most. Maybe some of them would even be like over, stacked on top of each other, and so wouldn't count. But the point is, to make a reasonably sized Christmas tree, you would, I guess, want it to be 2 or 3 times as tall as wide or something. I don't know. So is that right? Yeah, a Christmas tree would be twice as wide as it is tall. And it's shaped like a triangle. And the area of a triangle is 1/2 base height. So it's just base squared, basically, right? Because height is... no. It's height squared? Because the base is twice the height. Yeah. So it's height squared. So if we're going to use up about 500 robots, on something whose area is about the square of an integer, what number are we looking at? 20 something? 22, 23? Somewhere in that neighborhood. So and that's the height. So it's going to actually be kind of small. Small enough that you could fit it into a terminal if you focused on it. And we could do that. But I think maybe the more important insight is that you don't have a lot of robots to spare to make a reasonably sized Christmas tree, right? So if we just said step, what do the robots look like at step 1? What do they look like at step 2? And so on. And then produced a frequency or like a count of how many different positions are the robots at. Well, no. Because probably, like most of the time, I was thinking, my idea was, if the robots are covering in order to produce a Christmas tree, the robots will all have to be mostly at distinct positions. So we could just say, how many distinct positions are there at time 1, at time 2, at time 3, and so on. And when that number suddenly gets suspiciously high, we could say, that's probably the Christmas tree, and then either render it or just guess it as the answer. But of course, most of the time, most of the robots will be at distinct positions because they're only filling up like 0.5% of the space or something like that. Yeah. So, or wait, is it 1%? Because it's 100 by 100 is 10,000. We have 500. Yeah, 20. So wait. Is it 2.5%? Because you have to multiply 500 to get to 10,000. You have to multiply it by 20. So it's 5%. You would expect to have some overlap on average, but not that much. So I don't think you can just use that. But I think you could say, for each robot, how many neighbors do you have? Or something of that nature. And when the total of that gets suspiciously high, maybe then we have an intentional image. Because then they'll all be adjacent to each other. We could just render every step, but like I said, my terminal is only so high, and I suspect Eric hasn't. How tall is my terminal anyway? 27. So yeah, big enough that you could fit 22 or 23, but you'd have to do some work to center it so that it, and trim the parts that you don't think are part of the tree, and that seems like a lot of work when we don't even really know for sure what a tree would look like. So that's why I'm trying to find these heuristics that a computer could solve of, is this likely to be a Christmas tree? So in a drawing of a Christmas tree, we would expect, I guess, to have perhaps an unusually high number of robots in the middle. Well, no, because the tree could be anywhere on the floor. You can't say, oh, they would be in the center. Like, it might be a centered picture, but it might not be. Maybe this is why Eric is guiding us to talk about quadrants. The Christmas tree will be rendered in one of the 4 quadrants. Perhaps. Does the problem statement say that? I assume not. No. But maybe we can do some quick... This might be one of those days where where I break apart my typical main function because part 2 wants to do something else. Although, I guess I could just write this in the REPL probably. Well, no, there's kind of a lot of work going on here. Like, I want this, right? Actually, this product should maybe even dip suspiciously low, right? If everything is in one quadrant, then instead of multiplying like 125-ish, so like if the robots were evenly distributed, you would expect the sum to be, the product to be something like 125 to the fourth power. What is 125 to the fourth power? 244 million? And the answer I submitted was 217 million. So yeah, the robots are evenly distributed most of the time. But if most of the robots are in the same quadrant, we should expect the product to be about 500, way lower, right? I mean, it won't be exactly 500 because some of them will be in different quadrants, but I think that might be the point Eric is trying to get to. All the robots are in the same quadrant. So what if part one, like what if I parameterized this by the number 100? Then I would have pretty much everything I wanted, right? So what if we said quadrant product takes a, do I have a type alias for number of steps? No, okay. Int input int. So quadrant product of num steps is this, but num steps oh. There you go. Nope, wrong. No, wait. This one should be int. This one, of course, should take a list of robot of A. Oh, well, since it's taking a list of robot, this is where I finally want. No, it's taking a. It doesn't need to be parameterized at all. You can just take an input. Right? Yeah. So I run main now. We still get the same answer. But now I have this quadrant product function I can play with. So let input equal, no, bind to input the result of preparing read file input.txt. Now I would like to write quadrant product oh, kind of funny. Quadrant product takes its arguments in the wrong order for this. Okay. Quadrant product input 0 to 100. What do you mean? Input is an input. Oh, okay, yeah. I put the backticks around the wrong thing. I wanted them here. So these are all in the same neighborhood, right? Except right here, it suddenly gets a lot smaller for a second, doesn't it? $10,000 is too many. Give me 1,000. So there's a bunch of things in this smallish range, and one that's like even. So how many digits is this? 8, right? And so is this. There's a number of these 8-digit answers. Okay. And there's about, how many of these 8-digit answers are there actually? 3, 6, 9, 10. And how many of these ones that start with a 1 instead of a 2? 3, 6, 9. Interesting. Just in case, let's give it up to 1,001 and see if we still have the same thing, or if we do get a 10th input that starts with 1, or 10th result that starts with 1. So 3, 6, 9, 10 that start with 5. 3, 6, 9 that start with 1. Okay. So if I had to guess, one of these 10 things that's 8 digits long is our Christmas tree, right? Well, wait a minute. How big did I predict the quadrant product would be? I said it would be about 500. This is obviously much larger. But that could be explained by it being centered around the middle, where a bunch of the robots drop out of the universe, right? It certainly is much smaller than the quadrant product usually is. So instead of sorting, then, let's say filter less than 2, followed by how many zeros? 8? So we do see this kind of alternating behavior. Where oh, and what about this one where there's a 4? That's kind of interesting, right? It's also in the same place as all the 5s, so but are they adjacent to each other? let's say we did this, but didn't sort, and like only get 200, because if there are 10 in 1,000, we should get a couple of them in 200. So can I find visually by inspection the place where one of these appears? It should be near the middle, right? I don't see it, actually. Actually, I guess I can use, I have a computer. There it is. Found it. And above it, yeah, look. The comma 5 thing is not adjacent to it at all. It's several steps away. Interesting. So there is some periodicity to this, of course. I don't really know what it is, but perhaps the 5s are when the robots are getting close to being a Christmas tree. Like, some of them are synced up, but not quite. I don't know. And then the 4 that we eventually get. So let's say we ask for 10,000, but I only want the ones that are really small, that start with a number less than. Yeah, this is interesting, isn't it? This only happens like, whoa! That's really small. So I guess I should be maybe noting these down, huh? Find out what the actual because like I could write part 2 to say like, hey, if the number is less than, whatever, then actually render the thing. But I don't have a good way to render, really. I kind of want to just, like, do this. I kind of just want to say, like, find me the indexes where this is true, and I'll just guess some of them. But this 32 is so much smaller. Like, it must be intentional, kind of? I don't know. So I don't want to just call quadratic product over the input. I also want the actual index. So I want to like zip with a function rather than map over it. Let's filter first. Zip with I to n and what is this right? I don't need parentheses here. This doesn't type check at all. So what is quadrant product? It takes an int and an input. Yeah, so that's why I did it this way. Zip width lambda n. Zip width is applied to too few arguments. Oh, that's true. So it's not actually zip width because I'm doing the zipping myself. It's just map. Oh, of course I want to look at the second. Let's see which ones of those are smaller. So after 645 steps, it looks like this. And then much, much later, 7,412. Okay, we can stop there because we already know it ends at that point. So what if I, like, while this is running, or while we're thinking here, start at 10,000 and go up. Oh, there's another one where it gets kind of small. Down to 46 million, but not all the way down to 32 million. Then it goes back. Okay, so this is clearly looping, right? We've found the resonant frequency of all the robots, right? They get into some configuration where this is their product sum. And then 5,000 later they get into this. And then, like, so the period of this appears to be, you know, around 11,000. But less, right? It's 10,403. And that's how much these differ by as well, 10,403. So these are the only two candidates I see for something that would look like an Easter egg that is a Christmas tree. That's kind of cute. He made an Easter egg a Christmas tree. I like that. Okay, so we can stop this. We know what the answers are going to be. We could try rendering what it looks like at this point. Or we could just try blind guessing one of these numbers. And then if it's wrong, try blind guessing the other. I think it should be this, 7412. But that's not a proof. So how would I render something if I wanted to draw the actual picture? I guess I could write it to a file, but like my terminal isn't. No, my terminal is wide enough. It's just not tall enough. So I'll be able to scroll to see the Christmas tree if there is one, right? Okay. So we can do this. Let's write it like this. Render takes a function from, it is a function, I guess, from put to int to string, I guess. A list of string. What exactly do I want? I want something I can print. I want it to be a single string. Not print. I want to be able to hputster it. Or just putster, I guess. So render of I and n is unlines of do y from 0 to height, which is 103. Which one? 103 tall. Am I supposed to say row is due here? I want to say like pure, I think. I'm gonna render a character here. Now I'm gonna render a string. And I'm gonna get the string by doing a list comprehension over x's, but I don't want to flatten that. I want, so I think I want pure of do. X from 0 to 101. C? Let's see. I don't know. I think I'm going to say pure. Actually, I don't need to name it. Pure of. If. Now we're storing our coordinates as x, y pairs. So if x and y member, is that a function? Or is it called, do you have to call lookup and throw away the result? Surely there's something like member, right? Data map. Strict, please. Why is Google so slow right now? Is it me? No, Stack Overflow loads just fine. Data map strict. Query, lookup, find. Yeah, there is a member function. Okay. If xy is a member of well, actually, you know what we can do? We can say case xy, and instead of saying member, we'll say optionally look up in G, and we'll define G later, of, if it's nothing, we'll return a dot, and if it's an int, representing the number of robots there, then we'll produce into int to digit of n mod 10. Hopefully there won't be more than 10. But I just thought it would be nice to show the actual number in case it did. So we'll see if it's actually exactly 1 or something else. We're gonna have to import that, I'm sure. Import data char. I assume the function exists. I don't actually know. Digit to int exists. There must be int to digit, right? Like, it'd be crazy otherwise. Where G is something from here, right? Well, actually, I guess I need this first. M from list with plus map. No, I don't want this map. So final position 2D. Oh, I do want this. Yes. Final position 2D size n of I, and size is 101, 103. Does this make any sense? No, of course not. I have a map of coordinate. What? Okay, actually, sorry, I gotta get up for a minute. Okay, I'm back, and we were type checking. Well, no, we were debugging. Is it called debugging if it doesn't even compile? Probably not. We were attempting to fix compile errors here. Okay, so I need to put some types on some of these functions because GHC has inferred something that is not what I wanted. G is a map from coord int to int, please. Whoa. Int and maybe? What do you mean? Oh, just n. There we go. Closer. So you're saying I have a map of map? No. Oh, map takes its, the lookup function takes its arguments in the other order, and I don't know. Okay. Binding for n shadows. I don't care. So what would happen? So I've parsed my input. What would happen if I said render input? What do the robots look like right at the beginning? They look like this. I should say put stir of this. There. So the robots are all over the place. Great. Now, what are the numbers that we found earlier that looked like they might be correct? 645 and 7412. Traverse put stir. First put stir dot render input of 645, was it 1712? I have to look up again. So there's a 5 in it, wasn't there? 1715 or something. 7412. 645 and 7412. Okay, that I saw a Christmas tree go by, man. Oh, okay. Traverse. Really? Whatever. Doesn't matter. That, I would say, is a Christmas tree. What Why is it so tall? Oh, right. Because, okay, hang on. So this is, I think, in the second one, right? So if I just said this. Okay. Yeah. So it is the case that this is kind of mostly all in the top left quadrant, I think. Okay, cute. So I'm going to do the rudest thing ever here. just thinking of this makes me laugh. Input to int. 7412 by inspection. So this is not a correct solution. It's kind of, I don't know. I'm not that satisfied with it, of course. I do like my repositories to be solutions to the problem, and like an archive of like the kinds of, I could go back and look and see, oh, how did I solve this? And this really doesn't have any of that, right? Well, I guess it has render. So I guess you could actually because how did I come to the conclusion that it was 7412, right? I ran I ran the simulation for every integer until I started seeing loops. And then I took the smallest one. And that was the one where it was a coherent picture. So, although I'm kind of curious, actually. Is this a different picture? Or is it just a mess that happens because it's like half a period away from the tree? Yeah, there's like a vertical strip here, but it doesn't seem to mean anything. Interesting. Okay. So we could actually produce a function here, right? I'll leave render in. Use to visually confirm the most coherent image is a tree. We could even, actually, we could use render. If I change part 2 a bit. Or if I change main, right? Yeah, why not? It'll be fun. Ish. So there really is a cycle. The robots do... Oh, which makes sense. Because... Well, no. Yeah. 101 and 103 are co-prime. I think they're both prime, but they're definitely co-prime. And... So the robots have a periodicity in each dimension, right? Which if 101 and 103 were both prime, they'd have a periodicity in the 101 dimension of exactly 101 steps before they get back to where they started in that dimension. And 103 steps east-west in the other dimension before they get back to where they started in that dimension. And if those are co-prime, which I think they are, it means that in 101 times 103 steps, every robot will be back to where it started in both dimensions. So you are guaranteed that. So we don't even have to search for a loop. we can just run the simulation for 101 times 103 steps, right? You know what? I'm sick of having size be size integral a chord a. There you go. Size is 101, 103, or is it 103? Yeah, it's 101, 103. Actually, don't I already have something named size and room size? Yeah, that's the problem. This. Okay, well, we'll just take this one out, and then the one here as well, and also the one I was about to put in my part 2. So part 2... is let loop length equal I don't know, why am I doing this in let? Why not put it in a where? Actually, maybe what I did here is more useful. So we're producing this from 0 up to loop length. What do you mean no dynamic? Oh, because I see. So this obviously needs to also be a named thing. This is all, it's all arrangements. It's minimum, it's first minimum by second of arrangements. But instead of input, I'm calling it R's for some reason. I'll call it input, why not, I guess. Minimum by, okay, we have to import that from data list. By the way, minimum by is a partial function. If we produced a non-empty list of robots, we would not have this issue. It's like, I don't know. Minimum by second, okay, what is wrong with you? What am I actually producing? I'm producing the quadrant product. Isn't that a number? Yes. So what are you upset about here? Oh, it's like minimum on or something stupid like that. Minimum by comparing second. Ugh, it's nice and flexible, but it's just annoying how many there are of these functions for dealing with comparing pairs of things. I think I could write minimum by comparing whatever, but minimum by, yeah. So if we look at minimum by, it takes not a function to like A to B and then it can compare the B's. It expects you to take A and produce an ordering. And so if you want, where is comparing? Data ord, okay. Yeah, so now like that. And there we go. And shadow something, size, shadow something. Leave me alone, man. Give me a 7412. It's a little slow, huh? So I did do this up to 10,000, didn't I? Yeah, 7412. Okay. So you could run this faster if you stopped the search earlier because it actually shows up. Well, I don't know. It's about halfway through, I suppose. So this is now something that computes the answer correctly. But wouldn't it be nice? Well, okay. Tell you what. Let's commit this. Yeah. Yeah, that all looks good. But now we can do something a little bit cute. Main equals do. I call it input, I guess. Read file this. Let P2 well, I don't know. Oh, I guess I should say prepared thing, right? Yeah, okay, sure. Let Easter egg equal part 2 of input, or Easter egg index time? Easter egg time? It's Easter egg time, everyone. Then I can say put stir render input Easter egg time, right? Yeah, it takes those arguments in that order. And I guess I can use a $sign here. And then I can print part 1 of input and Easter egg time. I can actually drop this. So just out of curiosity, how long does this take? No time at all. Yeah, it's much faster when you do it outside of GHCI. Great. Okay. So you get to see the Christmas tree, and you get the numbers. Perfect. Day 14. Draw that tree. I think the exclamation points are bash things. You have to use single quote. Okay. It would be a little bit nice to fix all of the compile warnings, wouldn't it? Now, there's not very many. One is here. I just call it... I refer to size. I'll just call it dim. And what's the other one? Just n. I'm shadowing n. We did it. Okay, that was a fun little problem. Part 1 was pretty simple, but it let me do a couple of cute things. And part 2 was at first frustrating, but Eric left enough breadcrumbs for me to think about, oh, okay, you know, what would a Christmas tree look like? And so I didn't have to resort to like printing out all of them and looking at them by hand. And in the end, I got, you know, everybody's favorite thing, which is a function to produce. Actually, I don't need this comment anymore, do I? No, whatever, we'll do that later, or maybe not ever do it. So we get the answers, and we also get to look at a pretty tree. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.